Hey Trig class, this is the notes for section 4.1 that we started in class on Friday, and now I'm just going to do the last couple of examples that I didn't get through in class. Where we left off, I believe, was we had gone through, we graphed, on the previous slide, we graphed the sine wave from 0 to 4 pi, and also the cosine wave from 0 to 4 pi. And then we answered some of these follow-up questions, kind of looking at the graph and determining from the graph and using a little bit, probably more of our knowledge of our special right triangles and values for sine and cosine ratios. So it's asking us where is the sine of x equal to 1/2 on not just between 0 and 2 pi or between 0 and 360 like we usually do, but all the way to 4 pi. So rather than having just the two answers between 0 and 2 pi, we actually end up with 4 answers. And the way we kind of looked at that was, if this is the value of 1/2, the y value of 1/2, and we saw that it intersected the curve 4 times, meaning there was going to be 4 solutions. And so just using some of our knowledge of like right triangles, and if we were looking at, let me change that in a second. So if we're thinking about, our reference angle for that, if we had a 1 and a 2 opposite adjacent ratio, that would give us a 30-degree reference angle right here. Now 30 degrees meaning pi over 6, and so that's where we're starting from. So pi over 6 is our first one. And then from there, if we're going into these different quadrants, so pi over 6, 30 degrees is in the first quadrant between 0 and pi over 2. And then again, in the second quadrant, those are the two quadrants where sine is positive, and we're looking at a positive 1/2, right? So between pi over 2 and pi, or between 90 and 180, there's going to be another one. Now you use that reference angle of 30 or pi over 6, and now you go, from 180, you go backwards 30 degrees or backwards pi over 6, and that will put you at 5 pi over 6. Now if we kind of continue on in that trend, we have, once we go past 2 pi, 2 pi would be like 12 pi over 6, and we have to go one more past that, so that would be that 13 pi over 6, right? And then 3 pi, if we're thinking over 6, that would be like 18 pi over 6. We go back one, before that, which would be 17 pi over 6. So those would be our four angles that have a sine value of 1/2. Okay, a similar process was used for the cosine, or it was the square root of 2 over 2. We're using like a 45-degree reference angle. Being negative, we had to do quadrants 2 and 3, and then went around and did the coterminal angles with those. What I hadn't really talked about yet was this cosecant one. It's asking us where is cosecant of x equal to 1. I think we did mention that cosecant of x is going to equal 1 wherever sine of x equals 1, because sine is the reciprocal of cosecant, and so sine of x would be equal to the reciprocal of this ratio, but the reciprocal of 1 is just 1. So then you could go to that sine graph, and we could look for where is the sine equal to 1, because that's where cosecant would equal 1. So we know right here at pi over 2, and then if we follow it again, that would be at 5 pi over 2. So those are the two answers for number 8. Okay, and then moving on, I wanted to take a quick look at the tangent and cotangent graphs. So I was going to have you enter these just into enter a y equals tangent of x in your calculator and graph it. And if you do that, you are going to see some waves that look something like this. I already entered those in here, y equals tangent of x. If you hit zoom trig, it kind of gives you a window that's a little beyond 2 pi. So I'm just going to change this. I'm going to put negative 2 pi. Whoops. Let me try that again. Negative 2, and where's that pi button? Is it this one? It's really small. Oh, that was I. And let's try one more time. Negative 2, and I wish I could make this calculator bigger. Well, let's do this the easy way, and I'm just going to say negative 6.28 since I can't see the pi button on here right now. Okay, so negative 6.28, that'll be approximate. And our x max will go positive 6.28. All right, and we'll graph from there. So now it looks more like our our graph that we have right here, and we're seeing, you know, we see like 3 full like tangent branches, I call them. It's not a wave function because it doesn't do the, you know, like what sine and cosine do, but it does have a repeating, you know, a repeating shape, and so we can say that it's cyclical. So that was the question here. It says, is the graph, is it periodic? Yes. What's the period? So to kind of determine that, if we examine this a little bit more, you know, like I went up to 2 pi and negative 2 pi, and what we saw in there was we had these 3 full branches in here, and if we think about some of the values, the tangent of 90 degrees, that was where we got, it was 0, right? Or I'm sorry, it was undefined, because when we do like think of our unit circle, right? So 90 degrees, or pi over 2, which is up here, and if we're going to that angle, the ordered pair at that point is 0, 1, okay? And so we know that tangent is equal to the y over x, right? So tangent of any angle is equal to the y coordinate over the x coordinate. So that's 1 over 0, which means that it's undefined, right? So tangent of pi over 2 is like 1 over 0, that's undefined. And so on a graph, the way that that appears is with a vertical asymptote. And so if we went negative pi over 2, which would be this way, we'd still have that same ratio. We just have a negative 1 over 0 instead. And so again, it's undefined there. In between those asymptotes, that's where one branch of tangent is going to fall, okay? And so our period, which is what they're asking about, is from negative pi over 2 to positive pi over 2. Okay, that full distance would be 1 pi, right? It's like half, negative half to positive half pi, so that's 1 pi. So that's what our answer is here then. What's the period? It's pi. Okay, so this is your, like your parent graph, all right? All right. Over here, okay, so now they want us to just kind of graph it by hand. So if I ever ask you to graph the tangent graph, all I really expect is that you do one of these branches, and it really only takes 3 points and then your 2 asymptotes. That's all that you need to do on there. Okay, so you're going to just, you know, at positive pi over 2 and at negative pi over 2, and then put the halfway marks on the x-axis there, because these are going to represent the vertical stretch, because pi over 4, which is 45 degrees, if we take the tangent of a 45 degree angle, right? So if we have a 45 degree angle, the tangent of that, because that would be 1 root 2, right? So if this is 45, or pi over 4, which is what we're showing there, the tangent of pi over 4 is equal to 1. So that's a good point that shows us, they call it vertical stretch, because if, you know, if we have a, like on the sine and cosine, when we put like a coefficient in front and it changed the amplitude, like it stretched it vertically, that's something that we're going to show here on tangent and cotangent as well, and we'll put it on that pi over 4 mark. For example, if there was a 2 in front of this tangent, then on the y-axis I would go 2 and negative 2 to show where that vertical stretch, you know, lies. So here, over pi over 4, and then up to 1, put a dot there, and then over to negative pi over 4 down to negative 1. And then through there you just sketch your, you're just going to sketch your branch like this. And that's all I need to see is just one of those branches. Okay. Now, with cotangent, kind of a similar idea. The shape is somewhat similar. It's just a little bit reversed. And then the asymptotes are in a little different spots, right? Because with cotangent, remember, so if I refer back to the unit circle idea, like what I did, for cotangent, we know that rather than y over x, like with tangent here, I had y over x, but with cotangent, it's x over y, right? So I need, for those asymptotes, to, you know, where it's undefined, it needs to be x over y, which means the y coordinate needs to be 0. Now, where does the y coordinate equal 0? Y coordinate equals 0 here at 0 or at 2 pi, and because that point would be 1, 0, and over here at pi, right? 0 and pi, that's where I have y coordinates of 0. That means that's where cotangent is undefined, because cotangent of an angle is x over y. That's the ratio. So when I take x over y, it gives me 1 over 0, or negative 1 over 0. So at these angles 0 and pi, that's where I'm going to have my vertical asymptotes. Okay, So that kind of, like, it houses the branch itself, kind of like here between negative pi over 2 and positive pi over 2, that houses one of the branches. And I could have kept going and put another one at 3 pi over 2 and then made another branch in between there. But to do one, I just have you do it right through the origin. And so you use half of the negative side and then up to positive pi over 2. But with cotangent, since we start at 0 with one of our asymptotes, then we just go to pi. And then it's almost easier to see that the period is just pi there. Okay? And then we also know that the cotangent of pi over 2, 90 degrees, so that's up here, right? At pi over 2, this angle up here. Well, the ordered pair for that one is 0, 1, right? So when I take the cotangent of that, x over y, that's 0. So I do have a point there. I don't have an asymptote. That's defined. It's equal to 0. Okay? Now, these other 2 points, you know, again, if I take the cotangent of 45 degrees, it's the exact same as the tangent, right? So instead of opposite over adjacent, it's adjacent over opposite. It's still 1 over 1. So I still get a value of 1 for that, you know, that cotangent of pi over 4. Same thing that I had here. It's just that it's kind of in a different position, right? So at that point is the same as this one. In pi over 2, rather than being undefined like it is here, we said that was 0. And then 3 pi over 4. Okay, so now we're in quadrant 2, right? So if we were doing that reference angle in quadrant 2, right? This would be negative 1, positive 1, and root 2. So the cotangent here, adjacent over opposite, is going to give us a value of negative 1. So that's down here. So that gives you the shape of cotangent right there. Okay, so that's kind of the idea of the basic graphs for tangent and cotangent. Okay, and then finally, I think I'm going to skip 11 because all that this is it's asking us to graph cosine. We've already done that one and extending it the other direction, so I don't think that's too difficult. But what I do want to show you is I want to show you how to sketch secant, and then also I'll do cosecant real quick. So when we sketch secant, we want to use its reciprocal function to help us do that. So the first thing that we do, we graph one wave of cosine. Okay, so we worked on this in class on Friday. To graph one wave of cosine, 0 to 2 pi, there's our one wave of cosine. Now, here's what's important to remember. Wherever cosine is equal to 0, its reciprocal function secant is undefined. So that's why I've got a vertical asymptote at pi over 2, because that's where cosine is 0, and also at 3 pi over 2, where cosine is 0. So those are important. I need to put those in there. Now, where cosine is equal to 1, the reciprocal of that is also 1. The reciprocal of 1 is 1, so that point coincides. So where I had a 1 value on cosine, I also have a 1 value for secant. I'm doing that one in green. Now, as these values go closer to 0, like for example, if this is 1/2 or something right here, the reciprocal 1/2 is going to be 2, so that's up here. And as these get closer and closer to 0, like 1/10, you know, the reciprocal 1/10 is 10. So it's going to, so as this gets infinitely close, these y values get really close to 0, their reciprocals go up, 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 and they just kind of follow this vertical asymptote. Okay, a similar thing happens here. This kind of looks like an upside down parabola, sort of, but that's not what it is, but that's kind of the shape that it sort of looks like. But the reciprocal -1 is still -1, and then as these values, these y values get close to 0, these ones start going, you know, close to negative infinity. You know, they're going to keep getting lower and lower. Same thing over here. And then this branch does a similar thing to what this one does. It's just kind of like it's reflecting back the other direction. Okay, so we use cosine to sketch its reciprocal function secant. Cosecant is done in a very similar way. I kind of threw that on the last slide here. So if we're going to graph cosecant, first thing we do is we sketch sine, because the reciprocal of cosecant is sine. So I do that one first, basic sine graph. Wherever you have 1 and -1, you're going to have those same coinciding points. And then wherever sine is equal to 0, vertical asymptote there, 1 there. And that, again, that's going to kind of house where between the, you know, that's where your branches approach as they recede away from its reciprocal curve. So as we're doing reciprocals of each of these y values, they get larger, going up like this. And then as we do reciprocals of these negative, you know, values here that are getting close to 0, they get really small and go down toward negative infinity. So we just sketch our branches. So what I'm actually graphing for cosecant is just the green stuff, but I use all this other stuff to help me get it in the right places. Okay, it's just these 2 green branches here. But that's it. Those are the basic trig function graphs. and then we build on that in the next lesson with doing some vertical and horizontal stretching and shrinking and a little bit of vertical shifting up and down. So that's it.